Hello everyone, welcome to our channel Web Designs. Now today we're going to start our new course which is all about React plus TypeScript. So now what we're going to do is first we're going to learn TypeScript. Then we're going to learn React with TypeScript together so that you have some basic knowledge on web development, where in this modern world we only use React, Svelte or Vue. So now we're going to learn about TypeScript in just one lesson. But that doesn't mean that you should watch a tutorial on TypeScript. So I recommend you to watch this, and then I recommend you to go to Udemy or YouTube and watch some advanced topics, how to use discriminated unions and something like that. So now first of all, we're going to start with the introduction to TypeScript. So you'll learn what is TypeScript and why we use it. We'll install and set up TypeScript, and then we'll compile TypeScript to JavaScript. And you may ask, why do you want to compile TypeScript to JavaScript? Because the web browser is not able to read TypeScript. So we convert that into JavaScript which the web browser can read. Then we will learn about type annotations and inference. We're going to learn about basic types like string, number, boolean, array and tuple. We're going to learn about inference versus explicit types. Then we're going to learn about the special types such as any, unknown, void and never types. Then we're going to learn about function and type safety. We're going to learn about the function parameters and return types. We're going to learn about the optional and default parameters. Then we're going to learn about function overloading and arrow functions. Then fourth, we're going to learn about objects, interfaces and type aliases. First, we're going to define object with type annotations. Then we'll create and use interfaces. Then we'll learn about type aliases versus interfaces. Then we're going to learn about advanced types. Then we're going to learn about advanced types and utility types. We're going to learn about your union and intersection types. We're going to learn about our type guards and narrowing. And also we're going to learn about utility types such as partial T, read-only T or pick T. And over here you may ask, what is T over here? So T is just a short form of type. Then finally we're going to work with modules and generics. We're going to import and export modules, which is also done in React. I'm going to give you an introduction to generics, and I'm going to use generics with interfaces. Then after you learn TypeScript, we're going to run React plus TypeScript. So first we'll set up React with TypeScript. We'll create a React plus TypeScript project with Vite. Then we'll understand the TSX files and TypeScript configuration. Then we'll write a JSX with TypeScript. So here, we don't write JSX, actually we write TSX. That will be converted into JSX, that will convert into JavaScript and like that. So now, then we're going to try out props and states in components. Third, we're going to use event handling forms such as event handlers, handling forms with control, components, and we're going to use the hook, use ref for form elements. Then we have React router with TypeScript. We'll set up the React router DOM. Then we'll do type routing, link and use navigate. Then we'll use dynamic routes and URL parameters with TypeScript. Then we're going to work with fx and refs. Typing using ref dependencies, using ref for DOM manipulation and also handling asynchronous fx. Then we're going to learn to fetch data and API integration. Typing API calls with fetch and access, handling and loading error states and defining types for API responses. But before we dive right into this course, there are some prerequisites you need to know. First, you need to know some knowledge about HTML and CSS for the styling. But over here, we're going to use Tailwind CSS, because Tailwind CSS is where we don't need to manually define the index CSS and all. We can just write classes that will automatically style everything for us. But then the most important part is you need to know some JavaScript, you need to know some intermediate things in JavaScript such as the spread operator and something like that. So now let's jump right into this course with the first topic, introduction to TypeScript. So you may ask, what is TypeScript and why do we use it? TypeScript is a powerful superset of JavaScript that adds strict typing interfaces and modern features to improve the development experience. Microsoft developed and maintains it. It is widely used in large-scale applications due to its ability to catch errors early and enhance code maintainability. So what is TypeScript? TypeScript is an open source programming language built that builds on JavaScript. By adding static types, it compiles to JavaScript, meaning that any JavaScript program is also a valid TypeScript program. TypeScript's main advantage is that it enables developers to catch any errors during development rather in runtime. So why use TypeScript? TypeScript offers several advantages over JavaScript. First, it offers static typing, enhanced code readability and maintainability, modern JavaScript features, better IDE support, and strong community and industry adoption. So now let's install TypeScript. But to install TypeScript, first you need to install Node.js. So to install Node.js, you can go to this link over here where you can download Node.js. And once you have downloaded Node.js, you can go to the terminal and type in Node-v. So once you type that, you will see your Node version. So after you do that, let's install TypeScript. So to install TypeScript, we need npm. And npm is Node's package manager, and it will come when you install Node.js. So npm install -g. So this -g flag means that you install globally instead of locally, and then we just write TypeScript. Alright, so now let's install TypeScript by saying npm install -g TypeScript. Alright, so now what it does is install a TypeScript compiler. So we can say tsc-v, and we should see TypeScript's version over here. Alright, so now let's set up a TypeScript project. So to do that, we'll first do ls to see where we are. I'm going to go in desktop, and over here I'm going to say clear, and I'm going to create a new directory. So mkdir, I'm going to name it TypeScript course. So let's press enter, and now we're going to cd into our directory. So now over here we're going to initialize TypeScript by saying tsc-init. So what this does is create a TypeScript config file. So let's press enter. So now here it has created. You can press ls, and if you see, we have created a tsconfig.json. So now let's get our IDE in here. So our IDE is a VS Code, which is a very good IDE because it supports TypeScript. So you can just press download for Mac, and once you have done that and set it up, it will look something like this. So now here we're going to press file, open folder, we're going to go to desktop and our file. Alright, so now let's try exploring this ts.config. So now if you look over here, you can see that a lot of things are commented out. Because you can just uncomment it out and write your own thing. So we have our target, which is ES 2016. We have modules, common.js. And we have type check-in, we are setting strict to 2. I need to find, and I'm going to create a folder called .js. Just called JS, because this is where our compiled TypeScript files are going to go. So to do that, we should locate something called out.dir. So now here we're going to uncomment it out, and we're going to send it to JS. So now let's just write a test file called test.ts. And over here for TypeScript.ts is an extension. We're going to write nothing over here because we can just compile an empty TypeScript file. And we're just going to say tsc test.ts. So now it's going to compile it. And it seems that I haven't given the correct file path. Okay, let's try changing the name of it to JS files. And let's try it now. So I'm going to copy the name. And let's try compiling it now. Let me try invoking the compiler. And now it looks like it's working and JavaScript is in here. And some of you might be wondering how I got this texture pack. For that, you can go to extensions over here. So extensions. Then we can say material icons. So over here, so material icon theme, you can install it, then you have this beautiful icons. Alright, so now let's get right into the course, but first let me delete these two. I'll keep test.ts, but let me delete this. Alright, so now let's do a simple function called greet. You won't know some of this, but it's just a simple function so that I can show you how the TypeScript compiler works. So we're going to create a function called, so first I'm going to name this test to example compile.ts. I'm going to name this to 1. So we're going to have this function over here. So we're going to name it as greet. You know this. I'm going to pass in a parameter name. And over here, this should be always a typed string. And it will always return a typed string. So now you won't know this, but I will explain it to you later. So you're going to return a formatted string. Hello. We're going to put a dollar and then brackets, and we're going to just put our name here. So now this will always return a string. So suppose over here I say greet, and I pass in over here a number. So now we get an error over here as because argument of type number is not assignable to the parameter of type string. So some people don't know this, who doesn't know this function might just pass in a number. So to stop that, we return this parameter as type string so that we can only pass in a parameter of type string. So we can write my name over here is Shank, and over here we're going to compile this just using tsc example compile.ts. So over here we're just going to run the global ts command, and it's going to generate it in here. And by the way, if you run it again, it won't generate a new file, but it will just edit the old file. And if you look here, there is no type such as colon string or the return type or anything like that. That's only here. And if we make any changes here, and when we compile it, it will always come back to this same thing. So now over here, we can go over here and we can edit this ES thing. So instead of getting ES 2016, we can do ES 2024 or 23, which will set it to a newer version of JavaScript. So if you set it to a very old version, it will try to compile it, but it will have some extra boilerplate code. So that's why we only set it to ES 2006, which is the default, or higher. Alright, so now let's get right into this course. But before we move, I wanted to tell you the format we are using. So first, we're going to create a file called ts, and in that file we're going to have a module such as module number 1, which is about the introduction. So we'll create a new file called module 1, and we'll put it right in there. And over here we're going to we'll do the same thing, module 1, and put this right in there. I'm going to rename this to JavaScript for easier comparison, and Visual Studio Code is automatically going to update it to JS over here. Alright, so now that's done. Let's get right into this course. Now over here, you could do also one thing. By automating it, you can say ts-watch, but this is always not a good practice, but you can still do it. So now let's get into our second module, which is type annotations and type inference. TypeScript introduces type annotations to enforce type safety while supporting type inference, where the compiler automatically determines types. So we have the basic types in TypeScript, such as the string, which is used for text values. So we're going to just create a variable message, and we're going to say let it be the value of string. Then we're going to say hello TypeScript. Then we're also going to log this message, and we should always print a string, as because this type over here is a string. Over here, in these are called example boxes, and I will code in these, and if you want the programming language is used in, it's right over here. So now this is TypeScript, and let's try to replicate it. So this is module 2, and in module 2 we're going to create our example 1 file, and don't forget to write the extension .ts. So now here we're just going to write a string. So we're going to create a variable, let message, and then we're just going to assign it a string. Now we can give a value to this string. Now over here we can say message a string. We can say hello, but we can also say a string, but we can also say a number. But over here number is not assignable to type string, as because over here we say that this should always be of type string. But since over here we are assigning it to a number, TypeScript will give a compiler error, or you can say is actually figuring out when we write that code. So we can say equals. So now over here we can say let message colon string equals hello. Now if you hover over this string, it will say message equals string. If you try console logging it, so console.log message, then we can compile it by saying tsc, you go here into module 2. So now over here when we compile this into module 2, look, so these two are same, right? So now you'll just put it right in here. So over here it uses this use strict feature that JavaScript has, so that you still have some of the features that TypeScript has, but not all features such as the type annotations and some other things. So we're saying over here let message equals hello and console.log message. So you know how to run JavaScript files, right? You can either use code runner or you can use Node.js. So we'll say node/js/module 2/example.js, and it will print hello. Alright, so now let's make it simpler by naming it string over here, and also over here string, and make sure these file names are same, as because if the file names are not same, TypeScript compiler will create another JavaScript file. Alright, so now let's go back to the PPT to learn about some more types, such as the number. So here we have created two variables, let age colon number equals 25 and let pi number equals 3.14. So now you get the idea that if we put a number over here, we must assign a number. We cannot assign anything else. So now let's try it out. So in module 2, we're going to create a new file called number, and you should probably also give this to number, or yeah, let's give it numbers. Alright, so now in numbers we're going to create a variable, a simple variable such as a number variable, and then we're going to give it the type number. So now this type number is where you can only assign a type number. So we can say it as 25. But you may be expecting that there should be something called float, but there's nothing called float. There's only a type called number, but you can also assign floating points. So let's declare another variable called pi and give it the same number value, so number, and then say equal to 3.141. So this is the value of pi, right? And TypeScript is not giving us any errors, as because this is still a number, but it's a floating point number. So TypeScript doesn't now have two types of different values for number and for floating point digits. It has the same type number for both of them. So let's try console logging both of them. So console.log, I'm gonna log number, comma pi. So now you know how to compile. We just write the tsc command, and then we write node-js/2.number.js, and it prints out the two numbers 25 and 3.141. So now you may ask, what about the boolean values? So we have Boolean values is just two values, true or false, right? We declare a variable is logged in. We say its value as Boolean, and we set it to true. So now you can also set it to false, because that's also a Boolean value. So now let's create a new file called 3.boolean.ts, and over here we're going to say let is logged in. That's a Boolean value, and we're going to say it as true. So now let's try console logging it. Console.log, and we're going to log is logged in. So this is obviously going to print true, but we can also assign it to be a value of false. So we can say is logged in equals false, and we can also print that true. So now we can just compile it again, and then we will log. Then we'll use the node command so that we can actually do boolean.js, and we'll print true and false. So now this also works for an array. So now you need to understand this array concept, as because it's really important. So we're declaring let a variable called names, and that has a value of an array. But look at the type we assigned it as string and then an empty array. So this tells that this array should only contain an array of strings, and you can do this with numbers or booleans also. But you can also use the generic syntax such as let IDs, and we can put our type as array and then angle brackets, and in there our type. So now let's try that. So we're gonna put 4.array.ts, and what we're gonna do is say let names, and then over here we're gonna say it's a string of arrays. So we can say equal to, and then if you try putting an array, it's okay, it's an empty array. I'll put my name, my brother's name, and I'll try to put a number, but then it gives us an error, as because number is not assignable to type string. But you can make it a string number, and that's still okay, as because it's a string, not a number. And the same can be done with something like numbers, an array of numbers. So we can say number, and we put this syntax over here. So number and then our array, and we can put over here 1, 2, 3, 4, and then let me try putting a string of hi. Then it will give us an error, but then we can just replace it with 5, and it won't give us an error. Or we can also put it to any value we want, such as -1, and that's still a number, as because a number of arrays, as because it's a number of arrays and not a whole number of arrays. So this number can be negative values, it can be fractions, something like 3 divided by 4 is a fraction that makes 0.75, so that can still be a value in this array. But then we have also the generic syntax. We can say let IDs array, which is a built-in type. And if you look over here, we're getting an error, as because array is a generic type, needs 1 argument. So we're going to put our angle brackets and pass in something like number. So now what this means, that this array should only have a type number, and if you try assigning just 1, it will give an error, as because it's a type of array. But if you try putting an array and put a string in it, it will also give us an error, as because string is not assignable to type number. So you can just put a array of numbers. So now let's try console logging this. So console.log, log everything. So names, we also log numbers and also IDs. So now let's compile it. So tsc, then we'll say node, and we'll copy this file path, we'll paste it in, and then we'll say 4 and just press tab, and it'll automatically complete it for you. So now if you look over here, it's printing us an array of strings, an array of numbers, and an array of another number, which is our IDs. So now let's look at our final type, which is tuples. A tuple is an array with fixed types and order. So we can create an array called person, and over here instead of an array we're going to give it a tuple. So we just give it an array and we'll give it the types and the order of the types should be in, so that we can only assign John, which is a string, in the first place and a number in the second place. So now over here, if you wanted an index values, it's 0 index and the first index, and these indexes should match together and the type also, so that TypeScript won't give an error. So now let's look at this. We'll create a new file 5.tuple, not outside. So we'll create a new file called file.tuple.ts. So now in here we'll create a variable called name and numbers, and we're going to assign it a type of a tuple. So the first place should be a type of string, then the second place should be a type of number, and I'll add another type such as boolean. So now we can say equals to an array of the first thing, which is a string, the second which is of type number, and then the third which is of type boolean. So that's true. So now TypeScript accepts this. But if I add another thing called an array of strings, so I'll say an array of strings, so I have to give a nested array over here. So I have to give an array of strings. So I'll pass an array and put a string in it. So now I had some values to these strings, so such as my name over here, my brother's name, and a fruit such as apple. So now let's try console logging. Console.log. Then we'll write names and numbers, which is not now that suitable. We'll just write tuple. Let's paste it here. So now let's compile it using the TSC. Then we'll say node./js module 2/5.array tuple.js. So now the output is our array that we just wrote over here. So now it's time that I introduce you to a very good thing called CodeRunner. So you may have heard of CodeRunner if you're experienced, or may have not heard of CodeRunner. If you don't know, if you just started with Visual Studio Code. So CodeRunner is an extension in Visual Studio Code, and it can run JS but not TypeScript. So that's what we need. As because we don't need to type node and then our file path, we can just use CodeRunner. That's why you get this play button over here, so that you can just go to a JavaScript file and run it. And if you look over here, here's your output. So now let's go back to our PPT to learn more. So now let's learn about type inference versus explicit types. So now first is explicit types. You can explicitly declare the types of a variable. So now over here, this is what explicit types means. So now we're creating a variable and giving explicitly a type. But there's also something called type inference, where TypeScript knows that this city is of type string, because you're assigning it a string, and this score variable is of type number, as because you're assigning it a type number. But for the best practice, you have to use explicit types for function parameters and return values while relying on inference for variables. So now let's create two TypeScript files. So 6.explicit, and we have to write .ts over here, and over here we're going to create a variable called id, which is of type number. We'll set this to 1, and give another one such as string, and we'll set this to a value of high. So now over here I will write explicitly that this should be of type string. So we can console.log this. So console.log, and what we're going to do is we're going to say id comma string. So now once we save this, and then we're going to compile it. So we're going to say tsc, and it'll automatically and it'll compile it for us. But for every time we had to write tsc, it will get quite annoying. So what I'm going to do is say tsc --watch, which will watch any files. So what this does is watch any TypeScript file, every single one in your laptop or any setup or phone, and it will watch every single TypeScript file for any changes. Even if it's a new one, it will automatically add it. So we can go to explicit.js and run it. And if you look over here, it will output 1, which is our variable 1, and then hi. Alright, so now let's look at inference. So we write 7.inference.ts. So now here we're going to say let age equals 23 and let name equals Joe. Alright, so now do you know why we're getting an error? As because over here, so we're going to say let name 1 Joe and also let name 2 to some other name such as Jane. And now if you look over here, if you hover over, it will say age of number. So now if I try saying age equals a string such as number, it will give an error saying string is not assignable to type number. But if I say name 1 equals 1 and such as name 2 equals 2, this won't work, as because TypeScript already knows that this should be of type string and also this should be also of type string. So now if you look over here, TypeScript is watching our files and automatically converting it for us. So we can go here and run it, and obviously it won't print anything as because we had console log. So console.log, and we'll log all of our variables, say age, comma, name 1, comma, name 2. So we can go here and just run it, and it will say 22 Joe and Jane. So now let's learn about the special types in TypeScript. So first we have the any type. So here we declare a variable called let data :any equals hello. So here what any does is you can assign any value to this over here, and this will change its value to that. Suppose we can create a new file over here saying 8.any.ts. Alright, so what this is going to do, we're going to create a variable called data, and we will set this type to any. So now what any does is we can assign anything to it. So first if it was something like 1 2 3 4 5 x 1 2 3 4 5, so if it was 1 2 3 4 2 5k, now it will be, now data will be 32. Then data will again be of a boolean true. So what any does is remove the TypeScript safety features, and now we can assign anything to data. If we try console logging it and we want this initial result, we won't get it as expected, as we will get true, as because TypeScript goes by line. So now let's try running any, and if you look over here, it's saying true, as because over here we have in TypeScript over here we have used the any file. So we say any and we have assigned it to a string. We are saying this variable over here should be of type any, and my personal advice is you should avoid this type any over here at any circumstances. So now let's learn about the next type, unknown. So what unknown is like any but with stricter type checking. So here we're going to say let input, and we're going to say it as type unknown. So we're going to say input equals hello and input equals 42. But over here we have to check if type of input equals string, then only we console.log input dot to uppercase, which is a function that is only accessible by strings. So now again we'll create a new file that says 9.unknown.ts. So now over here what this file is, so in this file we're going to say let a value input, and we're going to set its type to be unknown. Then we're going to say input is first a type of number, so and TypeScript allows this, so no error. And we're going to say input equals string hello, which is also okay by TypeScript. But when we say input dot to uppercase, which is a function that's accessible to strings, it will say input is of type unknown, so that we don't know the value inside. So what we can do is do an if check. If type of input is equals, and if you look over here, Visual Studio Code is giving us great ID, great IntelliSense. So if it's of type input, then only we run this code. So let's move this up. So then it will work. So we'll just console.log, .log. And once we do that, if you try running this, it will give us, forgot the brackets. Alright, so now you have to put the brackets here. Alright, so now once you do that, once we run this, it will say hello in all uppercase. So over here, this is called type narrowing. You'll learn about this in our later courses, in our later lessons. But what you need to know is unknown is like any, but with stricter type checking. So if you ever want to write any, don't write any but write unknown, which also has some stricter type checking. Next, we have void and never, and these two are both for functions. So if we have a function called log message that we give a string, and then we console.log message, but we're not returning anything. So here we'll just put return type as void. So the function does not return anything. So first we're going to create a new file called, so we're going to say 10 dot, we're going to say 10 dot, and our type name, which is void. And void means nothing, right? So this function that we're going to create will return nothing. So we'll just log message. So this function will give an argument called message. So this will get an argument of message, and this should be of type string. It will not return anything, so it should be of void. And over here we're just going to write console.log, and over here we're going to log message. So now over here we can just call this function log message, and we'll say hello. So now we'll go over here, and when we try running this, it will log something to the console saying hello. But over here, it will never return anything, as because we don't have a return statement, or it will never ever return anything. So that's why we said it as void. But say a return statement and we return message, then it will give us an error, as because type string is not assignable to type void. And you might ask, this doesn't make sense, but it will make sense as because we're saying the return type is of type void. That means that it won't return anything, but then we're returning message, so that's why it's saying type string is not assignable to type void. Alright, so now we have the type 4. We have the fourth type, which is never, which is also used in functions that never return. For example, throwing errors or infinite loops. So this is a function that throws errors. So it gives a message, and over here the type is of never, as because it throws errors or it gives infinite, or it's an infinite loop. So through new error message. So not returning anything, but that doesn't mean that we should use void. We should use never, as because we're throwing an error. We'll create 11 dot never dot ts. So we're going to create a function that throws, that will be named throw, that will be throw error. So it will return, it will get error message, which is of type string, and what it will do is it will throw new error. So the error is the error message that we have just defined. So now over here, what the return type over here is never, as because it's throwing a new error. So we say throw error, and the error shall be not expecting type string. So now if you try running this in the JavaScript file, it will now throw an error. Alright, so now if you look over here, error not expecting type string. So that's our error. So now we have a final two types, which is null and undefined. And now you may know of this in TypeScript. So we are explicitly setting a variable as null or undefined. So here we're going to create our new file called null, called 12.null/undefined.ts. So now we're going to say let null. So we're going to set it as null. So for null, there's only one value, null, that we can put it as. And also, alright, so it looks like it has created a file. It looks like it has created a new folder. So I will rewrite it again. So 12 null and undefined. So here we'll create a constant called null. We'll say it equal to as null, suppose. So here null is not allowed as a name declaration. So we'll say is null. We'll say a is null. So camel case is required. So is null, it is null, and we're going to put it as type null. So we can only set this to a type of null, and const it is undefined. And then we'll set it to as undefined, and we'll say it equal to undefined. So now we can console.log this. So now when we console.log this, it is null, comma, it is undefined. So now over here we can just run this and we'll print null and undefined. I mean, there's no particular use for these two types, but it's still there in TypeScript. So now let's go back to our PPT for our fourth types called additional types. So now there's some additional types such as union types, literal types, and type aliases. So now let's learn all about them. So now let me close some files over here. So I'm going to close some files. Okay, so now over here, union types allow multiple types for a variable. So it can either be a type string, a type number, or a type boolean. Who knows? But once you assign it, it will be of that type. But then you can also reassign it to another type such as type number. So now if you look over here, we said let id equals of type string, or, so that's what this pipe is for, or number. So over here it can either be a type string or type number. So we can say id equals abc123, or we can say id equals 123. So now let's try it in TypeScript. So we can say over here, we'll say 13 dot union types, which are they're called. I think I got the spelling wrong, so let me change its name to union types. So now let's delete the one which is of the bad name, and over here in union.ts, what we're gonna say is we're gonna declare a variable. So let number or string be of type number or string. So now we can say let number or string equals a string such as a, b, c, d, e, f, or so number or string equals a, b, c, d, and we can also say number or string. We can also say number or string to be of 1, 2, 3, 4, 5. So now over here TypeScript accepts both of them. So you can accept number or string, and then we can also write or boolean, and then over here we can say number or string equals true. So the union types are that when you require specific types to be combined together. So you want a variable that can be either a number or a string. So then you can use union types. So I'm going to delete the boolean over here, and now over here this variable number or string can have values of number or string. Then we have the literal types, which restrict values to specific literals. So we can say let status equals success or error. So over here instead of types we're writing strings, so that when we declare, when you give a value to status, that can be of the value success or that can be of the value error. So now we can create a new file in module 2 saying 14.literal types, and don't worry, I'll fix the names later. And over here you can just delete the bad names, so just delete this, And over here, we're gonna write a variable such as let stats equals. Okay, now instead of that, let's say hertz. Let's say ping equals. So you may ask, what is ping? It is just how fast the internet speed is. It can be either it can either be 175 or 125. Let it be that. So now over here we can say ping equals something like 175, and I just realized that this should not be in strings. So ping can either be 175 or ping can be 125. So here TypeScript gives us great intel sense, so that we know that it can either be only 175 or 125. But then we can't assign it to something like 134, as because over here this can be only of 175 or 125. So this gives us an error, as because the values over here are not assignable to 134, as because its ping can only be assigned to 175 and 125. So now we have a final thing, which is type aliases, where you can create and define your own custom types. So you might think that's actually a dream, as because you can create custom types like custom union types or objects or anything like that. So now let's create a custom type. So these custom types are actually called type aliases. So type aliases. Oh, so now let's name it that, and we'll say let. So instead of let, we're going to say type. So to create a type, we have to say type. Then we give the name such as type of ID, and over here this ID is going to be an object where the key is name, that should be of type string, comma, or you can also write semicolon, but I like comma. Then we write age, which is of type number. Then we can also write something like phone number, or you can also write city, which is another string, but we can also give it a literal such as New York or LA, which is Los Angeles. Then we can say let ishunk ID, and this should be the same way as ID, our type. So we can say equals, and now the first thing should be name. So name should be always of type string, so that is ISHNK. Then I write a comma over here. Then age, which should be of type number, so we can say age as 12. And city should always be of either LA or New York, so I'm going to choose New York, and I forgot to write comma over here. So now you can print. So now you can console.log it, so we can say console.log, just gonna print ishunk.id. So now if we can go to JavaScript and go to the JavaScript file, and if you look over here, the type is gone, because that is of TypeScript's features and not of JavaScript's feature, so TypeScript will automatically delete it. And over here, if you look, we have our object. Alright, so now we're going to start with our third module, which is about functions and type safety in TypeScript. Functions are fundamental blocks of TypeScript, and type safety ensures that inputs and outputs adhere to expected data types, reducing errors and improving maintainability. So first, our function parameters and return types. So now, explicit parameters and return types. TypeScript allows you to define parameter types and enforce return types. So if you look over here, we have a function called greet. We given it a parameter of name, which always should have a type of string. So if we give it a parameter, it should always be of type string. Then the return parameter should always also be of type string. So we are returning anything, that should always be of type string. So then we return hello, which is in a formatted string. That's why there's backticks over here. And then the dollar curly braces syntax, where we put our parameter name. So now over here, this is just a simple console.log where we call the function and pass in our parameter. But over here, if we try returning a number, it will give an error as because this function can only return a string. But if we try passing the parameter as a number, this will give an error as because string type number is not assignable to type string. So now let's look at this example in Visual Studio Code. So now we're going to create a new module saying module 3. So in this module now I'm going to create a new file that is saying 1.functions parameter and return types, and this is explicitly. So I'm going to write explicit .ts, and don't forget to write the extension .ts. So now in here we will create a simple function called greet. So it's going to have some brackets, and this is our function. So in this function we're going to have pass a parameter saying name that should be of type string, and the return type should always be of type string. So now it's giving an error as because we have never returned anything. So let's do that right now. So we're going to say return and then backticks to get a formatted string, and in here we'll say hello, then dollar bracket syntax, and then we'll just pass in our name. So now over here what we're going to say is console.log, and in here we're going to call our greet function, and we have to pass in our parameter which will pass in Joe. So it's going to automatically compile, so we can just go here and just run it. So now let's look at the results. So if you look over here, it says hello Joe, but if we try passing over here a number, then we get a compiler error saying no overload matches of this call, and what is simply is saying that this parameter should always be of type string, but now you have passed in a number and that is not assignable to this parameter. So that's why we should always pass in a string. And now if you try returning a number, we get an error as because type number is not assignable to type string. So now let's go back to the PPT. So now you may ask, why use type annotations? While TypeScript infers return types explicitly, defining them will improve readability and prevents unexpected behavior. So here we should always define explicit type annotations as because we give more type safety, and also TypeScript will infer what we are exactly doing. So here we have a function called sum. We have a which is of number and b which is of number, and we should return a number. But if you don't explicitly define this, TypeScript may think that this a might be any because you can do concatenation with this. So that's why we should always explicitly define a and b so that TypeScript infers what we are doing. So the best practice are always specify return types for public APIs or library functions, allow inference for small local functions to reduce redundancy. So now let's go to two optional and default parameters. So optional parameters. By default, functional parameters are required, but you can make a parameter optional using question mark. So question mark is another example of a TypeScript feature. So if you write question mark after a parameter, so after a parameter we write question mark, it is guaranteed, it is optional, so you may want to write it or you may not want to write it. So here we have a function that says introduce, so it passes in a name, string, and a age parameter which is optional, which is of type number, and we have to return a type string. We are saying if age, so if age is not null or undefined, then only this if block will run, which will return hello, my name is this and I am this years old. Otherwise will return hello, my name is this. So now over here this is a simple function. Then we console.logging introduce Kiara, or console.log is introduced Ishan, 30. So over here if we don't pass in 30, it's okay, TypeScript will infer that this age is optional, so it will not give an error. But even if we pass it in, it will not give an error as because this age is optional. So now let's look at this using Visual Studio Code. So now here we're going to create a new file called 2.optionalparam.ts. Okay, so now here we're going to create a function called introduction, or you can say introduce is a better word. And so we're just going to create a simple function. We're going to have two parameters, a name parameter that's string, that is type of string. Then we have age parameter, which is type of number. So now can you guess what this should return? You may guess it right, because it should return a type string. And now we can write an if check over here to see if age is not null, and over here we will then return a formatted string that says hello, my name is, and then the dollar bracket syntax. So we'll pass in our name here, and I am, and then we'll again pass in the dollar syntax. So we'll say dollar and then bracket. So now over here we'll pass in our age, and then we'll say years old. And if it is false, then we'll also return another formatted string that says hello, I just realized I need to write name here, name is, and then the dollar syntax. So we'll just write name over here. Alright, so now this is a function. So we can say over here, we can console.log the output of this function. So we'll call introduce. So we'll say introduce over here, and we'll pass in our two parameters, name, which we'll pass in our two parameters. So our first parameter is my name, suppose Ishang, and over here we're getting an error because if we want to make this age optional, we have to write the question mark. So now what this does is make it optional. But you can also do something called the default parameter, which is kind of makes it optional. Something like null you can assign it as, but then, or 0, but then you also get I am 0 years old. So that's why we should make it optional over here. And now we can copy this and paste it again, and over here I can pass in 12. So now let's go to our compiled version of this, and let's try running it. So now if you look over here, it says hello, my name is Ishang. Oh, hello, my name is Ishang and I'm 12 years old. So now this is how you do optional parameters. And in JavaScript, you can if you look over here, this age is optional, but over here we don't write question mark, as because that's not a feature in JavaScript. That's a feature in TypeScript. Alright, so now let's go back to our PPT. So now we have learned about the optional parameters. Now let's learn about the default parameters. If a parameter is missing, TypeScript assigns a default value to it. So suppose we have a function over here called apply discount. So we're giving it two parameters, price, which is of type number, and discount, which is of type number. But if there's no discount provided, what it will do is discount it by the default value, which is 10. So the output will always, the return type is always of number. And over here we're saying return price minus price times discount divided by 100. So now what this does is discount it automatically. So now let's try it out. So in module 3, we're going to create a new file called 3.default.param.ts. So now in this file, what we're going to say is a function. So this function is discount. So this is our function discount calc. We pass in our number, or you can say it as value. So this value is of type number, and then we have a discount, which is also of type number. But over here we want to have a default value for this discount. So that's why we'll assign it to a default value of 10. So now we can do this, and then we can return price, or you can say value over here. That's what we written, minus, and over here also now we will over here say value, times discount divided by 100. So now this is our formula to find the discounted value. So now let's try it out. So we'll call our function. So we'll console.log it first. So console.log discount. We'll console.log our discount calc. We'll have to pass in our value. So I'll pass in $2,000 and I'll discount it by 50%. So now if you know, this is 2000 discounted by 50% is 1000. So now let's see if that works. And we'll have another value which won't have any discount, so it will go to 10 because that's the default discount or the default value for this parameter, you can say it as. So now it's automatically compiled. So now if you look over here, the default parameter is actually also a feature in JavaScript. So now let's try running this, and if we scroll down, we'll see over here 2000 discounted by 10% is this much, and 2000 discounted by 50% is 1000. So now you got the values correct. So now let's go back to our PPT. So the best practice is always to use default parameters instead of handling undefined inside the function. And you may ask, how are you going to get undefined? As because in the optional parameters over here, if age, we don't pass anything in age, it will automatically be undefined. So now let's go to our third topic, which is function overloading. So TypeScript allows function overloading where function can have multiple signatures. Alright, so over here we have a function called combined. We have two parameters a comma b, and both have the type of numbers and its return type is number. But we are again saying that function combined a or b, a comma b, which is both a string and it should return string. So then we are finally declaring it. We're saying a equals any, a and b are any, and it should return any, and we return a plus b. Alright, so now this is function overloading. So instead of what it will be is this a can either be of number or string, but over here it either has to choose one. If this a is number, then b should be number and it should return number. But if this a is string, then b should be string and it should return string. So now we are console.logging the output of combined, which has 10, 20, so that will be 30, and also concatenating the string hello, world. So now let's see it in Visual Studio Code. So here we're going to create a new .ts file. So for function overloading .ts. So now in here we're going to create a simple function called combined. This function will obviously be something like this. So we'll have a comma b, which should be of type number and of type number, and it should return a type number. Alright, so now this might give an error because we have to declare it, but we'll do that. So let me just copy this line, and over here let me edit it to be of type string, and type string. So now we're going to finally declare our function. So function combined. Now a over here should be of type any, but you just have learned that type any is a really big deal because you should never assign anything of type any. But here it's okay because we are using function overloading. So over here that this a should be of type number, then b should be of type number, the output should also be of type number. So now we'll just put brackets and we'll return a plus b. So now let me just give some spaces over here, and now we can console.log, and let's first try adding two numbers. So 10, 20. Then let's try concatenating some strings. So I'll say hello, which is of type string, and world, which is also of type string. But we can put a hello, which is of type string, and a number, which is of type number, and this will give an error because there's no overload that matches this call. So here this function is only of types numbers, but then this function is only of type strings, but there is no overload that says type string plus type number will return string. So that's why it's giving us an error. So let me try commenting it out and saying error. Alright, so now let's try running this. So over here we have our JavaScript code. So now if you look, there is no method overloading because this is only for TypeScript, not for JavaScript. But over here JavaScript allows numbers adding together and strings concatenating together. So that's why over here we just wrote our combine function and we just returned a plus b. So if you try running this, it will say 30 and hello world. So now let's go back to our PPT to learn more. So now let's learn about arrow functions. So if you are a JavaScript nerd, you may know about arrow functions, which are like small functions that you can add to variables. So TypeScript supports arrow functions, which provides a concise syntax. So let's look at the basic arrow function. So it's the same as the function. We have a variable called const. We have a variable called multiply. We have declared it using const, which equals a, which equals the arrow function, which is the anonymous function, where we pass in our two parameters. So a, which is of type number, and b, which is of type number. Our return type is of type number, and then we write the arrow syntax over here, and then we say a times b. So if we try console.logging 5 multiply 5 times 3, it will give 15. So now let's try this out. So in here I will say 5 dot arrow function dot ts. So now in here, so in this file we're going to create a const variable saying multiply, which equals a arrow function. So in our parameters we'll say a, which is of type number, and b, which is of type number, and then over here in the brackets we'll say a times b. So now we can also take care of these brackets by just deleting them. And now this is our simple one-liner function. So we can just say console.log and then we'll say multiply, which is our function name, and we'll pass in 12, 78. So now this should be able to multiply it. So now let's go over here, and if you look, this is just our simple arrow function that we just defined. So now if you try running this over here, which is in our JavaScript folder, try running it, it will say 963. So now that's the correct number that we wanted. So now let's go back to our PPT to learn more. So now we have tried out the basic arrow function, but now let's try it with default parameters. So now we are saying a const, so we're giving a arrow function, so its name, so we are passing in only one parameter, which is name, which is of type string, which is equals guest, which is also equals of type string. So now let's learn about arrow functions with default parameters. So now we have a simple arrow function over here. So its name is greet user, has a parameter, a single parameter of type string that is equal to guest, and its return type is obviously of type string, and we just have this formatted string that says welcome, the dollar syntax, and just name in it. Alright, so now over here we're saying console.log greet user, which is greet welcome guest, or console.log greet Ishank, which is greet welcome Ishank. Alright, so now let's try that out. So in module 3 we're going to create another new folder called, so now in module 3 we're going to create another new folder called 6 dot arrow function with default param, and param means parameter. Alright, so now we're going to say const, oops, forgot the extension to this. So yeah, we have to write the extension of .ts. So here we're going to say const greet, and this will be a variable that has our simple arrow function. So name colon, and this is our type string, which equals our default parameter, which is guest, and then our return type should be of type string, which then should have an arrow function that points to a return. Actually, I want to change this name. Instead of the name, I will actually like saying greet person. And by the way, don't forget the brackets when you're doing this, because it will try inferring something else. So now over here we're returning a string which is a formatted string actually. So here we'll say welcome and a dollar syntax. So we'll say dollar bracket greet person and exclamation mark. And by the way, do you know why we're getting this error that's saying cannot redeclare blocks curve variable greet? As because in another function somewhere over here have opened up a thing called greet. So let me try deleting all of these files and let's see if the error goes away. But it didn't go away. And now let's just so now here have changed the name to greet user. Alright, so now let's try calling this greet user function. So I'm going to console.log greet user, and I'm not going to pass in anything over here, and another greet user where I pass in my name. So now let's go to our arrow function, our 6.arrow function defer parameter.js, and over here let's try running it. And now if we look over here, this is welcome guest and welcome Ishank. Alright, so now in our PPT, let's talk about the rest parameter. So which is the spread operator, and args. Functions can take variable length arguments using the rest operator, or you may also call it as a spread operator. So we have a function that says sum all, and then we're saying we're going to spread all the numbers into this numbers array, which will always return number, and then we're saying return numbers.reduce. We're passing in acc and curr, which is another arrow function to acc plus curr, comma 0. What this dot reduce function needs is that it needs a function and it also needs a value, an initial value. So the initial value is 0, and over here we're saying just add acc plus curr. So now over here let's try it out. So now over here I'm going to create a new .ts file that says 7.rest param.ts. So now in here I'm going to create a function that says add all numbers, and this takes in number, which is of an array of numbers. So number array, which will always return a number. So now we're saying numbers dot reduce. So now this reduce actually accepts a function and a initial value. So in this reduce over here we're passing acc and curr, where we add acc plus curr, and we're going to return this. And now let's try saying add all number, and over here we're going to pass in 1, 2, 3, 4, 5. And over here we're saying add all numbers, so we're going to add this array of numbers. And over here that's why we're saying this spread operator, so that we spread all of it onto a number of array of numbers. And then so that's why we can accept over here a list of numbers. So now let's try going in rest param.js, and let's try running this, and we should get 15 over here, but it returns nothing. Oh right, we have to console.log it. So now let's try console.logging it. So we're saying console.log, and now if you go here and try running it, we get 15. Alright, so now let's go back to our PPT. So you may ask, what are the best use cases for this rest operator? When a function needs to accept multiple arguments dynamically, and when you want to build utility functions to sum, merge, or etc. So now let's learn about our fourth module, which is objects, interfaces, and type aliases in TypeScript. TypeScript provides powerful tools for structuring and defining object types. Objects can be explicitly typed using type annotations, interfaces, and type aliases, allowing for strong type checking and improved maintainability. First, defining objects with type annotations. Objects in TypeScript can be explicitly typed to define the shape of their properties. So now if you look over here, this is a basic object type definition. So now we're saying let user, and in here we're saying name should have value of string, age should have a value of number, and isAdmin should have a value of boolean. So now user is an object that should have this exact structure. So then we can assign user name, comma Ishan, comma that age equals 30, comma age2 equals admin. So now let's look at this using Visual Studio Code. So here we're going to create a new folder called module 4. So in module 4, we're going to create a new file saying one.type annotation, and let's say object type annotation.ts. Alright, so now in here we're going to give a variable. So let user, and this type annotation is this. So now it's a name, that should be in string, a name, and that should have a value of string. Then a age, that should have a value of number, and then we have isAdmin, that should have the value boolean. Alright, so now we're going to say just going to say user equals object. So this object should have name, that should be in strings. So name, that should have the value of Ishang. Then age, so age, that should have the value of number, so that's 12. And isAdmin, so isAdmin, that should have the value of a boolean, so true. So now user is able to be defined like this. But suppose we have another user, and instead of a age value that has a number, we give it a string of 12. Then we get an error as because type string is not assignable to type number. Alright, so now let's try printing this user. So that's console.log. This is going to log user. Alright, so now let's go in here, and let's go now in module 4. So over here, and if you see over here, the comments are still here, as because the TypeScript compiler doesn't ignore them, it just copy paste the comments in JavaScript and deletes all the type annotations there. Alright, so now let's try running this, and let's see what we get. So we get name, which is of type string, so Ishang, age, which is of type number, so 12, and isAdmin, which is of type true. Alright, so now let's move on to the next topic, which is nested objects. So now in here we're going to create a new variable called student. So it's another object type. So now in here we're going to say name, which is of type string, and then details, which is of type age, which is of type number, and grade, which is of type string. And over here, if you want to declare a value for student, so student equals name, which is of Bhavik, then details, which is of age 15, and grade 10th. So now let's try that. So I'm going to say module 4, I'm going to say 2.nested object annotations.ts. So now in here we're going to create a variable that says name user details. So I'm going to create a function called user details, and let me close some of these files over here. And in user details we're going to say its value as another type annotation. So now in here we're going to say name, which is of type string, then details, and in here is another nested object that has email, that has age, which is of type number, and email. And over here, if you want, you can even have another nested array, so such as mode of communication, so mode of calling, I would say, mode of talking, and they should have another object, and in there you should have phone number, that should have a type of number, and email, that should have a type of string. So now this is a type annotation of object that's nested in another object that's nested in another object. So now you may ask, how do we assign a variable to this? So we can say we're going to just say user details. We're going to say user detail equals, and in here we're going to say an object, so name. So over here name, which is Ishank, comma, and then we have details. So this should also be of type string. So in details, it's another object, and in details we have age, and age has 12, comma, then mode of talking, which is another object, and in here we're saying phone number, so phone number, and phone number should be of type number, so that is some random numbers like 1 2 3 4 5 6 7 8 9 10, or let's just leave it until 9. And then email is use of email at the rate of gmail.com, and don't forget the commas. So this is how you write this user details of type annotation in as you assign it. So now you can even take it more further, like in mode of talking you have a nested array that has nested, has nested, and you can take it until infinity, but I'm just gonna leave it over here, and then I'm gonna console.log this. So console.log user details. Alright, so now let's go to the JavaScript equivalent of this. So we're saying let user details, and we're defining all of this. So now let's try printing this. If you try printing this, it will look something like this. So now if you look over here, it says name of Ishan, treated as this, age of 12, and mode of talking in a single line. Alright, so now let me just minimize this, and now let's go back to our PPT to learn more. So the best practice, instead of defining inline objects, use interfaces or type aliases for better reusability. So now I may ask, what is interfaces or what is type aliases? I have taught you type aliases, but let's do a refresher on it. And interfaces I will teach you. Creating and using interfaces. An interface defines the structure of the object and that can be reused across multiple objects. So let's look at a basic interface. So here we have an interface of person that has name, which is of string, age of number, and is admin of boolean. Quite familiar to you, ain't it? And then we have const employee, so person, which inherits from person, so which takes all of these type annotations. So we have to say name, which is of type Isha, age 30, and is admin, which is of false. So now let's look at this using Visual Studio Code. So we're going to create a new file in module 4 called basic interface, and don't forget to write the extension for this, which is .ts. Alright, so now over here I'm going to say interface, which is a keyword. It needs a name, so I'm going to name it as person, which equals an object, so it should have a name value, and that should have type string, and also age, that should have a type number. Alright, so for interface you should not have this equal to. Now it will actually be correct. And now over here we can suppose have let person, it should have the type of person, which is our type, custom type. And so now let's define our object. So it should have a name that is of a string, so I'll just say hello, or you can say my name is Ishank, then a comma, and then we'll say age, which is of 27, or you can also say 12. And now let's try printing this. So let's say console.log, and we're going to log our person variable. So now let's go to our compiled version of this in JavaScript, and let's try running this using code runner. And if you look over here, there's this simple object with name as Ishan and age as 12. And now if you look over here, there is no interface, because interface is another feature of TypeScript but not in JavaScript, so it'll just automatically remove it. So now let's go back to our PPT to learn more. So now you have learned about basic interfaces. So now let's learn about interfaces with optional and read-only properties. So now you may ask, what are optional properties and what are read-only properties? Optional properties, are properties that allow objects to omit certain fields. But read-only properties, which are set by read-only keyword, are properties that prevent modification after initialization. Alright, so now let's try. So over here we're going to say interface with optional and read only parameters, read only param.ts, and in here we're gonna say another variable, or you can say an interface. So its name is a car, so it's a car interface, and in here we'll say brand, which is of type string, and this shall be set to only read only. So now over here, read only is a keyword that says that once you write a value to this, you can never change it, otherwise it'll give out an error. Alright, so now the car should have a module, so module, and that should have a type of string. Then year, which is optional, so year, which is optional, and that should have the type number. And now what we can do is initialize our object car, so we'll say let car, and this shall equal, and this has a type annotation of our interface car, and then it's an object, it will have a brand, so brand is a Lambo, then a model. I mean, I don't know a lot about Lamborghinis, but I'll write models such as this random model, I don't know. Alright, so now here I'll write the model as, alright, so the model is of Viano, or I don't know how to pronounce this. The model of the car is of this, and then the year, which is optional, so I'll write the year as 2012, or I'll write it as 2023. That's when I bought this made up car. Alright, so now but this year is completely optional, so you can just delete this and it will be completely fine. So now let's try editing our brand. So we can say car dot brand equals something. Now let's change it to BMW. But now we can't change it to BMW as because brand is a read only property. So that's why we can't change it to a brand something like BMW. Alright, so now let's try console.logging this. So let's say console.log car. And now if we go to our JavaScript file, which has the exact replica of this, and over here if you try uncommenting it, we can actually edit it out. So now if you try running the previous one, we'll say brand Lamborghini model Viano, but now if you say you'll edit the brand out, and now it'll be BMW model and Viano. So and you might ask, why is it only in JavaScript that we can edit BMW but not in TypeScript? But as because we have defined this interface that has this read only brand, so that's why in car.brand we can assign it to BMW, but in TypeScript we can't, as because over here brand is a read only property, but since there's no interface in JavaScript, so that's why we can actually edit this car brand. So now let me comment this out, and now let's go back to our PPT. So now let's try extending interfaces. Interfaces can inherit properties from other interfaces. So here we have an interface of employee, which has an ID of number and a name of string. So you all know this. Then we're saying interface manager extends employee. So the extends keyword is actually used in classes, but since interface is kind of a class that TypeScript knows, so we can say in manager extends employee, so that these two type annotations will come here, include, and we can write department of string. So if we write const manager equals manager, we have to write ID name plus department, which is of IT. Alright, so now let's try this in Visual Studio Code. Alright, so now py dot extending interfaces dot yes. Alright, so now over here what we're going to say, alright, so now what we're going to say is of an interface. So we're going to say interface, and over here its name is employee. So employee, and it has the interface of ID, which is of type number, and it has also a name, which is of type string. Alright, so now here we're going to create another interface that is of manager. So its name is manager. So manager. So manager extends. So the extends keyword extends employee. So our employee interface over here comes here. So now we're giving our brackets and we're saying department. And this also should have a type of string. So now we're gonna create a new constant called manager, which should have a type of manager, that should have ID, which is something like 1 2 3 4 5 6 7 8 9, and then also a name. I'll name it into Joe. Then we have department, which his department is IT. So now this is our manager, but even if one of them is missing, such as department, then we have an error, as because this manager extends ID and name. But then if Joe name is missing, it will still give an error, as because manager has an ID name, as because it extends from employee. So it just grabs the employees and pastes it in here. So now let's try console.logging manager. So console.log, and we log manager. So now let's go to our JavaScript file and let's try running it. And over here we get our ID, name, and department of IT. And if you look over here, the interfaces have also disappeared, because they're not a feature in JavaScript but a feature in TypeScript. Alright, so now let's go back to our PPT to learn about interfaces with function types. So you may ask, what are function types? So function types are that we define a function that we can use to create more functions of that same thing. So here we have interface math operation, and we're giving the type of a function. So x number comma y equals number, and then we say number, and it should also return number. So we have two parameters, both of type number, and then it should also return a type number. Alright, so now over here we're creating a new arrow function. So and we're giving it the type of math operation, which equals a comma b, and then arrow function a plus b. So now let's try that out. We'll go and create a new file called 6.interfaces with function types. So now in here, we're going to create a new interface. So interface, its name is math operation, and we have a function. So a, which is of type number, then b, which is of also type number, and it should return type number. Alright, so now we have a const and called add, which should have a type of math operation, which should equal a anonymous arrow function, and in here we'll pass a, which is of type number, but we don't even need to pass that because we have already defined it over here. So a comma b, and we should add it a plus b. Okay, so but it's still always a good thing to add the explicit types. Alright, so now it's saying a function whose declared neither type is undefined, void, or nor any must return a value. Alright, so now we are returning a value a plus b. So now this is our function, and now what we're gonna do is console.log add, which is 10 plus 40. So now this should be 50. Sorry, 10 comma 40. That should add up to 50. So now let's go over here where it's always simplified back into our simple arrow function with add with our two parameters, and just we are adding it. So when we run it, we get 50. Alright, so now let's learn type aliases versus interfaces. TypeScript provides two ways to define object structures: type aliases, which use the type keyword, and interfaces, which use the interface keyword. So here is the table on the cons versus pros for both of them. So you define interfaces saying interface person then brackets, but type aliases you say type person equals brackets. So extending, it uses the extend keyword, but for type aliases it uses the and or intersection keyword. It uses and or intersection. Then reopening can be redefined and merged, but type aliases cannot be redefined. Usage used for object types and function signatures, but this is used for object unions, parameters, and tuples. But I kind of prefer type aliases more than interfaces. But if you are creating a TypeScript library, you should use interfaces rather than type aliases, because they can be redefined and merged. So now let's define type using the type keyword. So to define a type, you can just say type user equals, then brackets, name colon string and age colon. So now if you look over here, we're using the semicolons and you can also use the commas over here, but semicolons are more often used because you have a habit of writing semicolons after the end of a line. And over here we're just using it in our admin variable. So using const admin user equals name colon Ishan comma age colon 30, which is allowed. But if either of these two are missing, or if the type is not same, it will be an error. So now let's look at this. So in module 4, we're going to create a new file, 7.typealias. That's what it's called, typealias.ts. So now we're going to create a type alias. So we're going to say type user, which equals name, which is of type string, and age, which is of type number. Alright, so now over here we're going to create our new variable. So const user is user. And over here, if you're generally declaring a type, you should always use uppercase as the first letter. That's just a common trick that we use so that we know that it is a type. Alright, so now over here the user is missing the both properties. So I'm just going to copy it, paste it here, and change the values. And I'm going to give name the value of Ishank and age as 12. So now over here since we have both names as user, and to avoid confusion, I'm going to say user 1, so that we avoid name conflicts between this type and user. Alright, so now let's try console.logging user, and you will feel that this type and interface are pretty much the same, and they have little to no difference, except that interfaces can be redefined and merged, but type aliases cannot. And yes, you're right, that's because that's the only difference that they have. But they have another difference also, so interfaces are only used in function types and objects, but type aliases are used in unions, discriminated unions, and many more. So now let's run this, and now let's see over here. So we have name, which is of Ishank, and age, which is of 12. And if you look over here in JavaScript, it's pretty simple, but in TypeScript we have a lot more boilerplate code to do. So now let's use type aliases for function types. So now to create a function type, we just say type math function equals, and then the same thing that we did use in interfaces. So let's see the interface one, and remember this one. And if you look over here, it's the same thing, but the parameters are just same or different. Alright, so now let's create another one saying 8.type aliases with function types, and don't forget to write the extension .ts. Alright, so now over here we're going to create a new type alias, math operation, which should equal just a simple method. So x, which should have the type number, and y, which should have the type number, and it should output type number. And don't forget the arrow function over here. So now over here it's But there's some differences, as because over here instead of writing colon, you have to write an arrow function. So now over here, this is how we properly define. So now this is how we properly define math operation. But over here math operation, there's some other TS files that have this name. So I'm gonna change it to math operations 2. And now over here math operations 2, I'm gonna copy that. And now I'm here, we're gonna create a add function, or we can say a sum function. But that's way too old, so I'm gonna say a multiply function, multi, which should equal. But first we should have to write our type, which is math operation 2, which should equal a comma b, which has an arrow function that should return a plus b. So now this is really simple. Now we'll just console.log, and we'll log 12 times 3. Let's log that. So now let's go to 8 type aliases over here, and when you press run, okay, so I see the error over here. Okay, first of all we have to put the multiplication sign, and over here we didn't even call the method, so I'll wrap this in more brackets, and we'll call math op multi over here. So now in this way we will save, and then if we run, we'll get 36, which is 12 times 3. Alright, so now let's learn about extending the type aliases with AND. Type aliases can extend using intersections, which use the AND symbol. Alright, so now we have over here type address. We have city, which is of type string. Then we have type customer, which has type name and age, and it's extending address. We have name, age, and city. Alright, so now we can say const client, which has the type customer. So we have to say name, age, and city. So now let's try that. We're going to create a new TypeScript file that says 9.typealiases, that says merging type aliases. And why do I always forget to write the extension? So .ts. So now let's get started. We're going to create a type called address. So now over here in this we only have one value, which is of type city. So the city is of type string. Then we have another type of type customer, and that should have the values name, age of type number, and then it extends or intersects, so that's why you use the AND symbol, address. Now we can just say that const client, which should have the type of customer, should equal name, which has a type of string, so it will be of Bhavik, age of 23, and write the comma, and also city, which is of type string, so I'll write LA. Alright, so now this is how you merge type aliases, but you cannot redeclare them. So that's what its weakness is. But interfaces, you can redeclare these. Suppose you have an interface, right, that has these specific types. So now you can redeclare them. Suppose you have name, age, but then you can redeclare the interface so that it has name, age, and then city. But type aliases you can't. So you have to merge them together. So now let's try console.logging it. So console.log client. So now let's go in over here, and if you look, it has been reduced down to just 7 lines, while over here in TypeScript we have done it in 16 lines. So now let me just press run. We'll get our object. So now the key differences are that interfaces can be reopened and extended multiple times, whereas type aliases cannot. Interfaces are better for objects due to their extensibility, and type aliases are better for complex types like unions or tuples. So now we have 4 using index signatures. So if an object has dynamic keys, we use index signatures. So over here we have an interface which has type dictionary, And over here we have a key that should be of type string, and over here we're saying that always should have of type string. Alright, so now over here we're saying const translations equals dictionary, so we're using our type dictionary. And over here we're saying that if the keys have, and over here if we have a hello, we should have, if we have a hello which is of type string, we should have a value of type string. So basically we have, if we have a type string as a key, then you should always have a type string as a value. Alright, so now let's try it out. So in module 4 we're going to create our 10th file. So 10.index signatures. So I'm going to write indexig, and in here we're going to use type aliases. So type dictionary, so dict, which equals an object where key is of type string, then should be of type string. We'll say const translations, so translations should equals, and over here we're going to use our type dict that we made. And over here if you try pressing 1:1, it will give us an error as because the number is not assignable to type string. So over here what we are doing is, if we have a key, it should always be of a type string. So over here we're going to say, we have to say something like hello, and we're going to say 1 2, but it will still give an error as because we should be also of type string. So we have to also give it of type string hello or hola. That's our translation of hello to another language. And then we can just simply console.log it. Alright, so now let's look at this in JavaScript. So now over here we don't even have an index signature. We just have this const translations, which is of object, and we're just printing it. So now that will return hola, hello equals hola. So the best use cases of this are when defining object with unknown properties such as API responses. Now let's learn about combining types, unions and intersections. So now you have already learned about unions, right? Unions allows multiple possible types. So if you have type ID, we can set it as string or number. We can say let user ID equals of type ID. So we can say user ID equals 101 or user ID equals ABC123. So now you already know about this, so I'm not going to discuss it to you. So now let's learn about the intersection types, which you know. But over here, this is a discriminated intersection. So we have two types over here, so type developer and type manager. Developer has type name, string, and skills, which is of an array of strings. Then we have type manager over here, which has only one key value pair, which is department, which is of type string. So the team lead should have developer and should have name, skills, and department. So that's why we say it's a discriminated intersection, as because we are using two types and assigning it to team lead. So we're combining developer plus manager and assigning it to team lead. So team lead should have name, skills, and department. And then we're saying const lead equals, and that we're assigning it a type team lead. And then we're saying which equals name, which is of type ishong, name which is of type string, skills which is of a type a string array, and then we have department which is of type string, so we wrote IT over here. So let's try it out. So in module 4 we're going to create 11 dot discriminated intersection .ts. So now in here we're going to create a type dev, which should equal a object. So now we're going to say type dev, which equals a object name, which is of type string, and skills, which is of type string array. Then we have also type manager, and over here we're going to say equal to as, and it should only have one thing, which is department. So department is of type string, And now we're going to have a discriminated intersection. So type team lead equals dev and manager. So now over here we're going to say a constant variable called team lead, and to avoid name conflict I'm going to say team lead 1, which should have the qualities of team lead. So you should have name, skills and department. So over here name is Ishang, comma, then we have skills. So skills is an array of strings. So let me write all my skills, such as I know HTML, CSS, Tailwind, and I'm going to write some more skills so that I can show you. Alright, so now I have listed a number of skills in this array, and now I'm going to, don't forget the comma. So now we are going to write the department. So department, which is of IT. Alright, so now let's try console.logging it. Alright, so now let's go to a JavaScript file which has this team lead one, but it never has the type aliases because that's only TypeScript exclusive. So now if we run this, we get over here, we get our object name, a skill which has a lot of things in the array, and department of IT. So now let's go back to our PPT to learn more. So you may ask when to use interfaces for defining object structures, and use types for complex combinations such as unions, intersection. So now let's move on to the fifth module, which is about advanced types and utility types in TypeScript. So first, let's learn about type guards and narrowing. Type guards help TypeScript determine the correct type inside a block of code using the type of primitives. So now if you look over here, here is a function, the processor input. So the input is either a string or a number. But now if we have to check if the type of input equals string, then only we console.log input to uppercase. Otherwise we console.log input 2.fixed to 2. So now over here, let me explain you something. If you say input or number, and if you try saying input dot to uppercase, types will give an error, as because this input can also be a number. So that's where we is first checking if this input is a string, then only we execute this, else we execute to fixed. And just to be clear, this input over here, the function for to uppercase is only exclusive to strings, and to fixed is exclusive to only numbers. Alright, so now let's look at this function in Visual Studio Code. So in the TypeScript folder, create a new folder called module 5, and in module 5 we're going to create a new TypeScript file. So 1 dot, and we're going to say type narrowing. That's what it's called. It's called type narrowing .ts, and in here we're going to say function that is named process input. So process input, and in here we're going to pass in a parameter input that is either number or string. And in here we're going to first check if type of input is equal string, and over here the Visual Studio Code IDE gives us great IntelliSense, and it only displays the types available by TypeScript. So if it's string, then we do return, then we return input dot to uppercase. Otherwise, so the else block, we return input dot to fixed to 2 points. And over here the to fixes the numbers floating point digit to only 2 floating points. So if there's 3 floating point digits, it will round it up to 2. Alright, so now over here, we're going to call the function 2 times, so console.log. And in here, we're going to create we're going to call our function, so that's process input. Then we're going to pass in a number, so 2.21222. And also we're going to call it using a string, say chunk. Alright, so now let's save this and it will automatically be compiled. So let's try running this. And now if you see over here, we get 2.12 rounded up to 2 decimal points, and chunk over here rounded uppercase. But if you look over here, we have our if check, but over here we never have our union type over here. So we can also say return input.fig to fix to 2, which will give us an error, but it's still a good thing to do if check even in JavaScript. So now this is what is called type narrowing. And over here it's also used in classes. Suppose we have a class car that has a function drive. We consider log driving ... Then we have a class bike that we have a function called ride, which is log consider log riding. And over here we have a function move, which has vehicle, which is either class car or class bike. If vehicle is instance of a car, then we say vehicle.drive, else we say vehicle.ride. So this instance of keyword is used for classes. So if this vehicle is instance of a car, then only say vehicle.drive, otherwise we say vehicle.ride. That is kind of rhyming. But now let's actually create it. So we'll say class narrowing .ts. And in class narrowing.ts, we're going to define 2 classes. So the first class is of car, and this class of car has our function called drive. So in this method, we just simply console.log driving. So now here, somewhere over here, we have defined a class named car or a type named car, which can also be a class. So that's why I'm going to name it BMW, which is a car brand. Then another class called bike, and in class of bike we're going to have a method called ride that will just console.log riding. Alright, so now over here we're going to create a function that will identify if the class is either BMW or bike. So we have passed in the parameter vehicle, which is either a class of BMW or a class of bike. And over here you might ask, how are we able to pass in BMW or bike? But they're not even type aliases or interfaces. Because type aliases and interfaces are classes. That's why when I was naming this over here car, I got an error because in some of one of these TS files have already created a type alias called car. So that's why it's giving us an error. Alright, so we're getting an error over here that's saying vehicle is declared but never is used. So that's why we're going to use it right now. If vehicle is instance of, if vehicle is not instance, it's just instance of. So if vehicle is instance of BMW, then when we call vehicle dot drive, otherwise we call vehicle dot ride. And over here you have to write the name. I'll write it as move. Also now this is a function that simply identifies if vehicle is either BMW, and if it is, we say vehicle.drive, and if it's bike, we say vehicle.ride. So now let's go to JavaScript, where we have basically the same thing, but over here we don't have a union type. And when we run this, it will output nothing, as because we don't have any instance over here. But over here, we create a new instance. Suppose the class of bike, right? So we're gonna say bike1 equals new bike, and then we can pass in bike1 over here, and over here in function we can call it the move function that will, and we'll pass in our bike1. Alright, so now if you run this, alright, so now do you know why we are getting the error? Because useStrict over here needs this to be declared with let, var, or const. So now let me try running this again, and we should get riding. Let me add ... And if you run this again, we should get riding. But now if you create another new instance of car, so BMW1 equals a new BMW, and now we can, if you want to pass, and over here we can pass in move, and in move we can pass in BMW, we can pass in BMW1, and when we run this, we get riding ... and driving ... Alright, so now let's go back to our PPT to learn more. So now we can also use the in operator for objects. So we have a type dog, which is of bark, which is a function. So we have bark, which has a function which returns void, and we have type cat, which has meow, which returns void. Then we can make a function called make sound, which is animal, or which has a parameter animal, which is of dog or cat, so the two function types. And if bark in animal, then only we say animal.bark, else we say animal.meow. So now over here you may ask, where is bark? So now over here, if you look, the parameter for this is bark. Sorry, the key for this object over here is bark, and so as for cat, which is meow. And I'm not going to show this in Visual Studio Code because there's nothing to output there, but we can still write this. Alright, so now we're going to say 3.object narrowing, and I should write .ts. Alright, so now over here we're going to create a type dog, which is an object that has bark, so bark, which is of a function that returns void. And you know about this special type called void, that means it doesn't return anything. And so as with cat, it returns meow, that returns void. So we can have a function that says make sound, and this make sound is a function, and what it does is accept a animal, which is either type dog or type cat. And now over here you can say if, alright, so now if bark, which is a key, in dog, or sorry, in animal, then we run animal.bark, else we run animal.meow. So now over here, if we look at animal over here, TypeScript knows that is cat and can infer it. And if we look over here, we know TypeScript knows that animal is of type dog. But if you look over here, TypeScript knows that it's either dog or cat. But if you try running animal.bark over here, animal.bark, TypeScript will give an error. You know why? Because property bark does not exist on type dog or cat. Property bark does not exist on type cat. So what this is saying, that this can be also animal over here can also be of type cat, and type doesn't contain this bark function, right? So that's why TypeScript is giving an error, so that we should do type narrowing. Alright, so now back in the PPT, now let's use utility types. TypeScript provides built-in utility types to modify existing types, such as partial t, which makes all properties optional. So now let's look at partial t. Alright, so now we're going to create a new file called for.partial t dot, and you may ask, what is this angle bracket t? So over here, angle bracket t means type. So over here you can create a type called user, then we can say const partial user, where we say partial and then we pass user, so that all of these are optional. So we're going to create a new type called user. You should have a name that is of type string, age which should be of type number, and then also city that should be of type string. So this is our user one type. Then we are creating a new const called partial user. So this partial user has the type partial, and we pass in our type over here because this is a generic function. If you look, so we pass in user 1. So now if you look at partial over here, partial is a generic function that accepts a type that makes all of these optional. So you can only define using name. So name can be just Ishank. And but over here, if you look, age and city is not optional. So how is this working? As because over here we had set it as partial. So that's why it's not working. So now if we go to our JavaScript, if we look over here, const partial user equals name Ishank. But if you go over here, we deleted this and also this. So if you try console logging partial user, then over here if we try running it, we only get name as Ishank. But over here, do you know what's happening? This partial utility type is making all of these optional, so that we can only write name or only write age or write age and city and omit name. So the use case for partial t is when updating a part of an object. Then we have read only t that prevents modifications. So suppose we have a type car that has brand string and model string. So then we have a constant my car that has a type read only car. So that we have brand as Tesla and model as Model 3. But then we cannot say my car.model equals Model S, as because that will give an error, as because these properties are all read only. So this is somehow what like partial t, where it adds question marks to all of them, but over here it adds a read only keyword to all of them. But you're not able to see them as because it's happening internally. So phi dot read only angle brackets t dot ts. Alright, so now over here we're going to write type, which is of car. So now this is going to have a model. So a model is of type string. Then we have brand name. So brand name. So we have brand name. So brand, which equals type string. And this is car 3. And over here, what we're going to say is const Tesla. Const Tesla equals, and we over here we add our type read only, and we pass in our type, which is car 3. And now over here we put our object in, that's car brand, which is of type string, so we pass in Tesla. Then we have the model, so I'm going to pass in the Model 3. Alright, so now over here let's try to modify the model. So we'll say Tesla dot model equals, and then we try modifying it to model 2. And now this gives an error, as because cannot assign model because it is a read only property. This read only utility type does is it makes everything read only. Alright, so now let's learn about the pick t comma k. So over here, pick T for type and K for the values. So over here, or you can say K for the key value pairs. And over here, we're saying type user, so name which is of type string, age of type number, and email of string. And we're saying type user info equals pick, then give our type name, then our keys that we want. Then we can say const user info, const user, and we pass in our user info type, where we only have to write email and email address, where we have to only write name and email address. Alright, so now let's try that out. So we write 6 pick T comma K dot TS. Alright, so now in here, what we're gonna do is we're gonna create a new type. So this type name is user, and this type name is user3. And over here in here, we're gonna say name, that's of type string, ID, which is of type number, and city, which is of type string again. Alright, so now over here, we're gonna create a new type called user info 3 to match with the name for user3. We'll say our utility type, which is pick. So pick needs 2 arguments, that is the type's name, so that's user3, and what things we want to pick. So we want name or city. Alright, so now we're going to do const user or const user4 equals, and it will inherit the types from user info 3. And over here, you might wonder what were the types. Was it name or it was city, or both of them are optional and you can write nothing? If you said that we have to write both of them, you're absolutely correct. Alright, so now we have to write the name property, and so the name property has string, so it's chunk, and the city property, so city, which is of type string, so we write New York. And let's try console.logging it. So console.log city, or you can say user4. Alright, so now over here, let's look at this in JavaScript. So now in JavaScript, it's really bland. We only have our user4, and then we just console.logging it, and we'll still get name as Ishank and city as New York. So now let me read out to you the use case for read only T and pick T comma K. For read only T, it's useful when you want immutable objects, and for pick T comma K, it's useful when you only need certain properties from a type. Alright, so now over here we have the omit T comma K, which removes specific properties. So we have our type, which is of user. So we have name, which is a string, age of number, and email as string. So we're going to say type user without email, which equals omit user comma email. So what we'll do is create a new type with only name and age. Const user without, and we're giving it user without email, and we're saying name colon Ishank comma age colon 30. Alright, so now this is an easy task. Alright, so now let's create a new file, 7.omit, and we'll say T for type comma K for key value pair dot TS. Alright, so now in here, what we can do is we create a new type. So type called user, which equals name, which is of type string, and age, which is of type number. Alright, so now we're going to create a new type user without name, and that's where we use the omit. So our type we need, which is user, and the thing we want to omit, which is age. So now something like this. So now we can say const user 5, const user without name, sorry, age. You have to do age over here. So without age, and we can write over here without age. We write 1 over here to avoid name conflict with the type, and this will be user without age, our type, which equal to an object with only the name key value pair. So the name only accepts strings, so we write ishunk. So now here if you try to write age, TypeScript will give an error as because age is not a property in use without age. So look, object literal may only specify known values and age does not exist in type user without age. Alright, so now let's go to our TypeScript file. Sorry, let's go to our JavaScript file. And now over here, if you look, it's just our single object that has a single key value pair. And if we try running it, and over here we had, first of all, we had console.log. So we'll say console.log user without age1. Then over here we can go and run it. We'll get name colon ishunk. So now over here the use case for this is when you want most but not all properties of a type. Alright, so now we're going to learn about the required T, which makes all properties required. So we have type user over here, which equals name, which is optional, and we have age, which is optional, and also name, which is optional. So what this required user does is it makes all of these required to fill out. So this actually only gets one argument, which is the type, and makes all of the properties required. Alright, so now let's try it out. We'll say 8.required and we'll pass in angle brackets t.ts. Alright, so in here we create a new type called user. We'll call it user with optional value. So here we can just say name optional of type string, and then age, which is optional, which has type number. So there we have then our constant, which is user with all values, key values required. So now we're going to set this to an empty object, so that if you write user with optional value, we can write it to an empty object. But if you write required over here, required, this is a utility function, we wrap it around, then we have to write name and age. So we have to write name, which is of type string, so we write type string, so ishunk. Then we write age, which is of type number. Alright, so now let's try console.logging it. So console.log and user with all keys required. So now here if we try running this, we'll get name, ishunk and age as 12. So this is what required T does, is that it makes all values required in a type. So even if all of them are optional, it will make them required. So now we have exclude T comma U, which removes specific values. So suppose we have a type status, which is a union, literal union type. Then we have a type active status, which excludes status of pending. So we have only success or error. Alright, so now let's create a new file. So we'll say line.exclude T comma U, and over here U means union types. So this actually requires a union type instead of a regular type. So we say type, and type can be status over here, can be of done or pending or error. and I'm going to change done to success. So now over here we're going to create a new type called active status with no pending, and this is equal to exclude, and then we pass in our type that we want to exclude, so status, and what we want to exclude, so that's pending. So now over here, if you hover over status with no pending, it will only give success or error. Alright, so the use case for exclude is when you want to remove unwanted types. Then if we have exclude, we have also extract, which is also for union types, which extracts a type of single union. So if you say extract, you say pass in T and then our union, which keeps specific types. Alright, so now let's create a new file. So we'll say 10.extract.ts, and I forgot to pass in t, u. And you may ask, why am I doing this over here and writing extract t, u? So that it's also clear for people who are reviewing these files. So over here we are creating a type of status again, and we're saying type error status. Alright, so we say type status 1, this is equal to, and I'm going to copy from the other one over here, and over here I'm going to say type only error, which equals extract. So extract over here, we're going to say we're passing our status, which is 1, so status 1, and what we want from there, so we want error. And now if you look over here, type or error, only error equals error, and we say only error and suppose success, so or and pending. Then we can pass in or pending. Let me just copy it and paste it here. Alright, so now if you look again over here, it will say pending or error. And you may ask, why is it saying pending or error if you said error or pending? As because it's taking the order this is in, and if you paste it in the other way around, and if you paste it the other way around, suppose like this, now if you look, it will say error or pending. So extract, the use case for extract is when filtering out a specific type. So now let's move on to our final module, which is working with modules and generic types in TypeScript. So this module has importing and exporting modules. Then we have introduction to generics. Then we use generics with interfaces. So now let's get right into our final module with an explanation on this module. TypeScript provides powerful features for modular code organization and type safety, reusable components using modules and generics. This guide covers important / exporting modules and generic functions and using generics with interfaces. So now we have the first part of this, which is importing and exporting modules. And we should make sure that this is in your brain, as because we're going to use importing and exporting modules everywhere in React. Modules allow you to split code into separate files and reuse components across projects. So now exporting from a module. A module is a simple TypeScript file that exports values. So suppose we have a function over here, so we can say export function, and we have our add function over here. Or we can export a constant such as pi. Then we can import them, and then we can import them using the import statement. Alright, so now let's try it out. So go ahead and in the TS file create a module 6. And in module 6, we're going to create another folder called example importing and exporting. And in there, we're going to create a TypeScript file, so which is math.ts. So this is our helper function that we have. So it's also going to be created over there. We're just going to create a simple function called add that takes two parameters, a which is of type number and b which is also type number. Then we just add them, so return a plus b. So instead of add, I can also see divide, that's another one, so I'm going to actually divide both of them. And also the output value should also be of type number. And to export this, you can just say use the export keyword. So export. Now we're going to export also a constant. So export const pi, which equals 3.141. And then we have our app.tsx over here. So, sorry, app.ts over here, where we import our divide function. So I'm going to copy that, divide, and also the pi from math.ts. So dot slash. And over here, you may ask, why are we using math.js instead of ts? As because it's finally going to be compiled into JS, right? So that's why we're going to use math.js instead of math.ts. And in here, we're going to say console.log, and we're going to log divide. So 4 divided by 2. And also we're going to console.log our pi variable that we just imported. And now let's go to module 6 and app.js. And over here, if you look, this is very messy. If you look, we're saying object.define comma export underscore es modules value colon true, and we're doing some funky imports over here so that we can use this. Because we are targeting an older version of ES where there is no import. So I'm gonna put it to ES 2000, ES 2024. So now if you go to app.js, so that if you go to app.js, you still remain the same, as because it's already been compiled. So maybe some changes it may work. I'm gonna add a new function over here, something like a multiply function, a multi function that will just multiply. And in app.ts, we're gonna import this multiply function. So you know how to do it, multiply, then just console.log multiply. And if you go to app.js, it looks like it's not actually using the import that is built into JavaScript, but rather it's doing this over here and importing it like this, as because maybe you use import this from that. So that's why it's doing this over here. I'm going to give some space, and over here it's saying math_js_1 dot divide, and then something like that. So now if we run this, we should see 2, 8 and 3.141. Alright, so now that's the basic exporting and importing modules. But we also have default exports, and over here this is what we use a lot. So we have, suppose, a logger.ts that will log a message. So we have export default function. So over here we are exporting it by default, and we are logging log, that's a function name. We're passing in a message that should have type string, and we're saying console.log message. Alright, so now over here in the imports, we're just saying import log from log./logger, and we're saying log hello. So let's do that. So we're going to create a new folder, but first let me rename this to one dot. So 1 dot importing, and now we'll create a new folder called 2 dot default importing, default exporting. And in here we're going to create a new file called app.ts. That doesn't change. And then over here we're going to create a new logger.ts. We'll create a new function that is exported by default. And over here we can say our function keyword log msg for message string, and over here we just say console.log msg. So this is a simple logger function. And in app.ts we can say import log from logger, and if you look over here, TypeScript, sorry, Visual Studio Code will automatically complete the sentence for us. And over here we can say log hello. And if you look at that, if you look at the second one, default exports, you go to app.js. Now this looks way more messier, as because now we have done default exports, so that's why it looks like this now. But we don't care about all the JavaScript, we just care about our output, which is as expected, hello. Alright, so now what I suspect is making this is I'm gonna run the tsx.watch command again, so that it's now used to this ts.config being at ES 2024. Alright, so now let's learn about exporting and importing types. So if you can export functions and all, you can also export and import types. So now here's our types.ts, where we're saying export type user equals and our type, and also we're importing user from /types. And we're also saying const user :user. We're using our user type we created in a separate file, and we're creating an object. So now let's do this example in Visual Studio Code. So we're going to create a new file called 3.exporting types. So we have app.ts and we also have types.ts. So in types.ts we are exporting a type, and the type's name is user, which equals, and in this user we have name, of course, which is of type string. We have age, which is of number, and also have city of type string. Alright, so now in app.ts we're going to import user from /types, and in here we're going to create a constant called user that has this type, so that has the structure of this type, and that should have name, which is of chunk. Then it should have age of type number, so that is something like 23 or something. Alright, 12. Then we have city, which is of type string, so I'll write New York. Alright, so now in here we're gonna create a new type. We're gonna create a new variable. So our variable name is going to be num array. So this number array has a type of a generic syntax of numbers arrays. So you can say over here an array of numbers. So that's why we write this over here, in here, and we say equal to as a array of numbers. So 1, 2, 3. And you already know that if you try assigning a string over here, it will give an error. And we can do the same thing with string arrays. So we can write string over here. We can change this to str, and we can change this to an array of strings. So something like hi, hello. Alright, so now we can just try console.logging this. Num array, str array. Alright, so now we can go to our JavaScript file that we have compiled and run this. And once we run this, we'll get an array of numbers from 1 to 2 and an array of strings hi and hello. Alright, so now in the PPT, let's go to the generic functions. A generic function preserves type information for parameters and returns values. So over here, we have a function that has identity and a placeholder value called t. So this t over here is called a placeholder type. Then we setting the value as t, and then the return type as t, as because we are returning the value that has the type t, so it should always be a return of type t. So now this is like a bypass also, and over here let's write a generic placeholder. And in there we have a function called identity. And that has a placeholder value called t, but you can name it anything else, such as y, k, values such as like hello, but I'm naming it t as because this is a common way that people write it as. Output value is also t, and over here we return value. And now if we try calling this by using the identity, so that's we do console.log, and then we do identity of function, and over here identity is a generic function, so we have to pass in angle brackets or type, which is number. So over here we have to write a number such as 12. Then if this is a string, we have to write a string over here, so it's short. But if this is a number, console.log, but if this is a boolean, we have to write a boolean. So a boolean is just true or false. But we can also write values such as object. So we have an object that has name of string, then we have age of number, and over here we can set it to that exact value. So name of string is chunk and age of a number, so a number is just 12. We can also set it to something like null, where we have to pass in null, or we can also set it to the any type, so then we can pass in any value we want, such as an array. But over here I will delete this. I'll write over here something. Alright, so now let's go to a version where we don't have the generic, but we can still return the values. Over here we have 12, we have a chunk, we have true, we have our object, and we have null. And if you look over here, I directly just copy pasted our comment. So if we uncomment it, we'll have our generic type any. Alright, so now let's learn about the use cases of generic functions. So generic function ensures that input and output types match. Then we have multiple type parameters. A function can accept multiple generic types. So we have a function, we have pair t, and also a union type u. But over here this u can also mean a union type or another secondary type. So first equals the value of t, and then second equals the value of 2, and then the output equals an array of t, a tuple of t comma u, and over here we're returning first comma second. So now over here what I'm gonna do is first copy this function over here so that I can edit it out, and I'm going to create a new file called generics placeholders generic with multiple placeholders.ts. So now in here I'm going to paste in the function I have function I have copied. I'm going to write t comma u, and over here I'm going to put first, which is t, and second, which is u, and then we're going to return a tuple, which is t comma u. So then we return the value first comma second, and over here we can say const. We can also do console.log. We'll call this function called pair, so we'll call the function pair. We'll pass in the generic values number comma string, and in here we'll put the values 12 comma chunk. Now let's look at our compiled file over here, and if you look, the generic placeholders are gone, and we just have our pair function. So now if we run this, we should see an array of 12 and a chunk. Alright, so now let's move on to using generics with interfaces. So now if you look over here, here is an interface called box, which accepts a generic value called t, and will give it a value called t. So now this creates an object, right? So that's why we're saying const number box colon box it accepts a number. So then over here we write value colon 42, and we can say that with same as string and say value colon hello. So let's try that out. Over here we're gonna put 7 dot, okay, so 7 dot, and we'll name it generics with interfaces. Alright, so now we're going to create a new interface, but first we have to write our TypeScript file, and we have to write the extension that I forgot to write, and now we write interface. So this interface will have box as its name, will accept a placeholder t, and then we'll give out a value. We'll have a key value pair of value which has a type t. So now we have a constant called num box, which has a type of box, which is a generic type. So we have to pass in a another type for its inference. So then we can just pass in value, which always should be type number. But we can also do it with the same as string. So we can write str box. Then over here we have string over here as its value, and then we'll write hi. Alright, so now let's do console.log on those. So console.log numbox comma string box. And now if you go to here and play, if you look over here, we have our object value, we have a numbox object which has our value as 4523, and we have a value, we have a string box which has a value of hi. So now let's go on to our last topic, which is extending generics. So suppose we have an interface that has length, that's name is has length, and it has a length. So we have a function that says log length, and t extends has length. So you have to provide, alright, so this t over here extends has length, so length has to be a number. So now we're saying we're passing in the argument as t, and it won't return anything else because we're console.logging it, and we're logging length as arg.length. And over here length should always be a number, so that's why we can say arg.length as because t extends has length. So now over here we're gonna create our final file called 8.extending generics in using interfaces.ts. Alright, so here we're gonna create an interface. The name is has length, and over here we're gonna create a length. We'll create a length that has a value of number, and then we're gonna have a function that calculates length. So that's why we're saying log length over here. So log length, and it's a generic function, so t that extends has length, it has arguments, so arg, that is t. Then over here it returns void as because we are logging it, and we'll just say console.log, and it's a formatted string, length of this, and then we'll just give a colon, and we'll write dollar this, and we'll write arg.length. And now if we say log length, and we pass in a string such as hello. Alright, so there was a small typo over here, so I'm gonna change it to a different code, and it also has some comments. So over here I have written the length spelling wrong. Instead of, I wrote this instead of this, so I have corrected it to this, and so over here, and now this should work properly. I'm gonna also log length of an array. So an array of 1, 2, 3, 4, 5. And now if we go over here, if we try running it, if you look over here, it'll say length as 5 and length as 5. So folks, that's it for today. Thanks for watching. If you like this video and want to support us, please like, share, subscribe to us, Kavya Designs, and keep on watching our videos and show some love. And this is Ishank signing off.